right there. This first line you see, this is essentially just a bash shell script. So that's why you see the shebang bin bash up there. This next section of lines, these are all PBS directives. As far as bash is concerned, they're all comments because they begin with this hash or pound or octa-4 symbol there. But since they have this special combination of characters, pound PBS, that means the PBS system will parse those and it will interpret all of these extra options as options passed to the qsub command. And so this is where you specify things like the name for your job and the exact hardware you require for your job, the maximum wall time for your job, and other things like that. The next section is where I'm setting up my environment for my job. I'm loading software modules, and this next line, I'm setting a variable that I'm going to use. This is completely optional. This is just something that I'm doing for this particular calculation. And then I'm going to cd to my PBSO work directory. The only thing this line is doing is it's just verifying that when my job starts running, I'm in the correct location. And that is the PBSO work directory is the directory from which I submit my job. So if I want my job to run in this location, which I do, then I will submit the job from there. And then I will use this cd PBSO work directory to make sure I'm running my job in the right location. The last line there, this is actually the command that I use to run my program. And this is a parallel program. So this is actually the executable, but I need this MPI exec-n and then some number of cores specified so that I will have a parallel environment set up for this parallel executable to run. And this next part is just feeding in the input file to that executable. All right, so I'm going to go ahead and run that job. Let's use qsub lamps.pbs, and that's it. My job has been submitted. I've got a PBS job ID number assigned to my job. I can run qstat-u and my username to check on the status of my jobs. I've only got one job running right now. There's the job ID number. There's my username. This Q assignment called tiny, I'll talk about that in just a minute. The job name is the name I specified in my job script. The number of nodes, that's the number of compute nodes that my job is spread across. This is a parallel job running across 4 nodes. And in total, I'm using 16 parallel tasks. I'm using 16 MPI tasks. And the total amount of memory that my job requires is 8 gigabytes. My job's going to run for a maximum wall time of 30 minutes. My job is currently in the status of R, which means it's running. If it was waiting in the queue, my status would be just the letter Q. And the elapsed time is in hours and minutes is 0 because it hasn't even been running for a minute yet. Just check that again. So it's still running. If I type ls, I can see now there are some files being created in this directory. The reason that's happening is because my job is running from this location. And so it's writing its output files in this location. I'm writing a trajectory file as well as creating this log file that this LAMPS program creates. And that's it. That's my job running. That's how I check the status. And you're welcome to start the same job if you'd like, or any of the other examples in there. Now, that page in the PBS User's Guide covers a lot of the available options for the qsub command. And you'll notice that these qsub options are the same things that you see in that job script. For example, the capital N is what I use to specify the name for my job. That can be passed directly to the qsub command in this way, or it can just appear in my job script. So all of those options that we saw in the PBS User's Guide, those are all things that can be included in your job script if you're running a batch job. or you can specify these things from the command line if you're running an interactive job. Either way works fine. If you want to specify a particular work queue, a particular job queue for your job to run in, you can do that using the -q. Most jobs, well, all jobs actually, will by default be sent to the work queue. The work queue is the primary public job queue for all jobs on Palmetto. There's no need to specify the work queue. That's just the default. Your jobs will go there anyway. The only time you need to specify a particular job queue is if you're using a queue that's not the default. If you're part of a research group where you guys have your own special job queue, then this is the way you would specify your job queue, using that -q option. If you're setting environment variables in your current shell and you want to pass those on to your job environment, then you can pass those on using a $V. If you want to set some environment variables from the command line as you run your qsub command, then you can do that using this $v. And the most important option for the qsub command is the -l. That's a $L. And that refers to your resource list, your hardware requirements for your job. If you look in my job script, I've actually got two of those -l lines that specify all the detailed hardware specifications I need for my job. And when you use the -l option, there's a lot of different possibilities you can provide. You can specify the number of nodes. That's what's select. It's typically just the number of nodes. In the PBS documentation, you'll see that's referred to as chunks of computer hardware. It can be thought of as nodes, but strictly speaking, it's not always equivalent to nodes. But just commonly, for beginning users, you can just think of it as nodes for simplicity. So that's the number of nodes, the number of compute machines. This is the number of cores per node. So in all, I'm here requesting 32 cores. This field, MPI procs, is for the number of MPI tasks. If I'm running a parallel program that uses MPI for parallel communication, then I need to specify the number of MPI tasks, the MPI procs, for this job. And in CPUs, the number of cores, and MPI procs, as well as the amount of memory I specify, those are all requested per node. So I'm going to be multiplying each of those features, the number of cores, the number of tasks, and the amount of memory, multiplying each of those by the number of nodes that I'm requesting with the select equals. And the last part of this is the wall time. That's the maximum time that I want my job to run. If I set a wall time of 2 hours and my job actually runs 2.5 hours, then my job is going to get terminated abruptly at 2 hours. My job will not be permitted to run longer than the wall time. The maximum wall time you can set is 72 hours. And you can set any wall time up to 72 hours. If you're part of a research group that has a dedicated job queue, then you might be able to run jobs up to 168 hours. But general users like me and a lot of other people can only run jobs that are up to 72 hours long. Some other things that you can specify with your resource limits or resource list are the chip manufacturer, if you want to specifically target AMD cores or Intel cores. You can also specify the specific chip models. In the Palmetto User's Guide, there's a detailed list, a more detailed list of the things you can specify when you run a job. Let's see if I can find that list for you quickly. Yeah, here we go. All right, this is in the submitting jobs to run on the cluster section. And those are the common qsub parameters. And down below, you can see examples of a lot of different detailed specifications that you can make. There are a lot more. This is not a comprehensive list. This just shows a bunch of examples that are important examples. Like specifying the number of GPUs, that's discussed here in this section of the Palmetto User's Guide. And if you specifically need to target the SSD storage devices, this is how you would do it. So be sure to take a look in the Palmetto User's Guide for the details of how to use these hardware requesting features.